This is a little rundown on doing electrical. This has got to do with engine performance, it's got to do with emissions, it's got to do with everything, because electrical is everywhere. If you go to work somewhere at a dealership where they've got, you know, a lot of workflow through there, and they decide they want to school you, one of the first things they want to school you on is electrical. Now typically what they'll do is they'll set you down in front of a computer, and the manufacturer, whether it's GM or Ford or whoever, is going to have a bunch of computerized stuff that's similar to this electude stuff. But y'all are all supposed to be working on that. I hope you're working on it, right? And if you don't, and I had one guy that hired on at a really nice GM dealer, and he was a good mechanic, he fixed stuff and all, but he didn't stay there very long. And I said, what happened with this guy? And he said, well, he could fix everything, but I couldn't get him to do the computerized training. And he said that was part of it.
Are you making a video?
Yeah, that was part of it. And I said, so the computerized training is basically what got him let go. He says, yeah, he would never do it. Didn't see the importance in it. And he says, but that's part of the deal. He said, I cannot send him to GM school until he gets those things done. Until he gets that, because they won't even accept him into school unless he's done the basics on the computers and all. And so this is sort of like that. So, you know, part of the thing is that electude stuff is that I got set up is going to be a huge chunk of your grade. You know, so don't think you're going to sail out of here ignoring that stuff and not do it. You need to get to work on it anyway. But electrical is something they want everybody to know. And this is every now and then I'll just give a few little, this is not an exhaustive thing, but it's going to give you a few little pointers that you can fill in the gaps with. And this particular one, the first thing you're supposed to do when you're trying to find an electrical problem is find the circuit protection point. Now you kind of got a little taste of this morning when we were looking at that expedition at Wooden Start. You find your circuit protection point, whether it's a fuse, whether it's a fusible link, you know, whatever it's going through, even if it's a circuit breaker. The first thing I need to know is, do we have power there? Check for power at and through that point, and locate a wiring schematic. I worked for 6 years, not ever having seen a wiring schematic until the first time I went to work at a dealership and I saw wiring schematics. I said, wow, now I can see how this thing's piped and I can fix it a lot quicker and all that. But a lot of the times if you're just shooting in the dark and, you know, jumping things and hooking stuff up and seeing if that works over there and that over there, you can wind up causing yourself a lot of problems and everything. Yeah, that's the battery. Yeah, that goes, set it over there by that. Hey, Randy, I think your key's leaving right there. Good to go. There you go. We'll get that other one out and send it back. Okay. But anyway, you got to determine the location of your relays, your connectors, and your other components. You have to be able to find those on the car. But if you've got a problem, you don't know. And I'll tell you something else. Find the easiest one to get to first. If it goes through a whole bunch of connectors going from point A to point B, make sure you say, well, which one of these is right up on top of the engine where I can get to it really easy. That's what you want to know. Determine the integrity of the circuit and determine the integrity of the component. All right. Now, circuit protection and power source is going to be your fuses and stuff. Is it B plus hot all the time, or just when the circuit's powered? Now, one of the things that's a little annoying is whenever I have people checking fuses, like if somebody doesn't know exactly which fuse to go to. You remember what we did? We basically, when we found out we had no fuel pressure on that 07 Expedition, I said, next thing we want to see how it's wired. Is it running see, there's a lot of them have a fuel pump module, you know, and that, you know, maybe I think a year or two after that they started doing that. And it doesn't go from the fuse directly through the fuel pump, I mean, you know, to the module, or you may not see a ground at that fuse, I mean, in that relay going to the pump on the ones that have a module. So you got to be careful to know how the thing's wired, or you'll confuse yourself. But anyway, the first thing we did, we went and found the fuse number F32. We went over there, what did we do? We checked if it had power on both sides of it. We needed to know, and the schematic told us it had B plus all the time. Now, if it doesn't have B plus all the time, you need to find out under what conditions does it have power. Is it with the key on? Is it with the starter in the start position? What is it? So check for power to and through the circuit protector. Is the fuse or fusible link open? Now, fusible links are something that we still see occasionally. You don't see as many of them as you used to. But that is a piece of wire that's a special kind of wire, and it's got high-pylon insulation on it. And it basically is made so that it can handle a heavy surge without popping. Like if you surge current through a fuse and it goes up over 10 amps, it's going to go pop. Well, this one right here, you have to have a dead short that stays there a while before it burns these up. And you might notice the wire is protecting wires that are bigger than it is. So it's going to be the weak link in the chain. The high-pylon insulation is basically made, is really heat resistant, And so if you have a wire that burns in two, it'll burn, you know, a fusible link wire burns in two on the inside, it actually, you can stretch it. So if you grab that and you can stretch it, you'll know it's burned two on the inside. It's not going to be feeding any power. Now there are some rolls of fusible link wire you can get from some parts suppliers, but I don't like it because it's just plain old copper wire. And the wire that's the expensive fuse links that they put on there at the factory, if you cut those open, you'll see that they've got some silver color to them. I don't know what the difference in the wire is. I never researched it, but I will tell you, a fusible link is a lot more than just a piece of copper with hypoline insulation on it. You've also got to get the one the appropriate size. It's got to be smaller than the circuit is protecting. That's important. If it's open, did it just get tired, or are there too many amps flowing? If there's a fuse that's blown, sometimes the fuse just got tired and old. Doesn't happen a lot, but you know, a lot of times you'll say, well, the fuse is blown, I'll just put another fuse in there, and if it wakes up and everything's fine, that can mean one of two things. Either the fuse got tired, or there was something shorted out. It popped the fuse. One of the things that was the spooky ones to me was when somebody come in, my stoplight fuse blows about every 3 or 4 days. Really? How you gonna find that? See what I mean? I mean, it may be just a momentary short. And in extreme circumstances, when we couldn't find a short, you have a question?
Mm-hmm.
And you moving your hand like you're
Right,
going to do.
that's going on.
Did you have yours? Was yours doing that? You know. So, but anyway, those intermittent ones are a little annoying. And if you're going to go to a fuse, like let's say that you're blowing this fuse right here. Okay, so if you take that fuse right there and you hook a test light to your hot side of your battery, and you make a connection with that fuse. I don't ram it in there so it spreads a connector, but you know what I'm saying. Set it in a side that's shorted, or that's shorting out. And then you start moving your harness around watching that light. And if you move your harness and that light comes on, you say, whoop, here I am right here. That's going to be it. And then if you can duplicate it, you can look around and figure out, well, but you need an indication of what's going on while you're moving the harness. It's really important. Now this is true for engine controls or anything else, you know. Locate the wiring schematic. Know how to find the right schematic. If you pick the wrong vehicle, if you pick the, one time when I was working at the Ford dealership over there, I used to be the one, I would take the, because of the way they were paying me, I always tried to stay busy all the time. You know, they paid me salary plus commission, so whatever I turned over a certain amount, they pay me, but they had I had a, you know, but because of the fact that they were paying me even when things were a little slow during the peanut festival time or whatever, I tried to stay busy all the time. I was blowing dust out of the computers, I was updating things, and they'd send these orange stickers, and I would go in and put them in the wiring schematic. It would say, go to this page in the wiring schematic and put this sticker here, and it would take them to another book that was published that had an updated wiring schematic. And I had put those stickers, and I just sit up there for, you know, an hour at a time putting those stickers in all the EVTM wiring books and all, to make sure everybody could go and find the accurate wire schematic. The shop foreman and another guy fought with about, I don't know, half a day with this Ford probe, and they couldn't figure out why the air conditioner stuff wouldn't work right, and it had them up against the wall just wearing them out and beating them up and all. They couldn't figure it out. They said, can you come and look at this? And when I looked at their schematic, there was one of those orange stickers. I said, how come y'all didn't, have y'all got that book, the TSB book that's got the updated wiring schematic in it? Well, no, we didn't think about that. So I went and got it and opened it up, and the answer was right there. It was the schematic was wrong. That's why I was beating them up, see? But anyway, make sure you find the right schematic. Understand the symbols. You know what that is. You know what that is. Now, sometimes a fuse is going to look like an S. Sometimes it's going to look like a box like that. But you can tell if it's a fuse because it's going to tell you it's a fuse, right? Just make sure you get to where you're familiar with those. And see these relays right here. Notice the role of any related modules, but be able to trace a current path. Okay, you know, how does this go? This goes from here, goes through here, goes to there. That's the control side of that. That's going to be your primary side. B plus right here is going to go through here, and then that's going to go out to wherever. You know, this is going to the sunroof and whatever. I just threw you a little schematic up there to look at. And this is a more of a modern schematic. Body control module, notice it's got a little switch built inside of it. Now, here's something I want you to remember. If you see a dotted line, that means you're not looking at the whole module. If you see a dotted line going between two wires like that, that means they're in the same connector shell. Always remember that. Don't forget that. You see a dotted line, you see a solid line, you're seeing the entire component. You see a dotted line, you're only seeing part of it. Sometimes the ground looks a little different from that, but you can always tell that's a ground. On some of your Mazdas, it's got a line around here and a picture of the car body to tell you it's grounded to the car body. Alright, so let me make sure I'm getting I got to trigger, there we go. Locate components and connectors. You saw this earlier. I pulled up something that looked kind of like this, and it gives us a little legend and tells us what's what, and where the connector is and all that. And if you've actually determined as you're tracing your wires, you say, I'm going to go to this connector and it's got power on this side but no power on the other side. Where's that connector at? Because you may be looking here and down yonder. In between there, 2 or 3 connectors. So you're going to have to find out which connectors they are. When you get the connector, pull it up, make sure the wire color is going through it that you're looking at. And you're going to test it on both sides. Unplug the connector and see if you've got, anything out of the way or push back pins or whatever. And determine how the wire harness is routed. You can find that by looking in there. Pay attention to the circuit, wire color, and the pertinent connector cavities. If you can go right to the cavity on that connector. See, this looks kind of complicated here. That looks like spaghetti. But you're hooking everything up one wire at a time. One wire at a time, one circuit at a time. Now what you got to do is you got to forget about all these circuits that have nothing to do with what you're doing and go and track that thing through every cavity and every connector, and you'll go right to where the problem is. And if it's got power at this connector, if it doesn't have power at that connector, and none of the wire harness in between, you've lost part of your wire harness. Usually, the smartest way to fix that is just run another wire and do a good job of it. You don't have to go to find the place. If you know that if it's only going from point A to point Z, and you know it's got to have power from here to there, and there's nothing branching off in between, you can get some loom and do a really good job and run another wire, and you can get that car fixed and out of there and nothing flat. That's one way to do it. All right, now, once you locate your components and your connectors, and that right there, so you basically pay attention to these cavities, and you got to know which color you're looking at and all that. I remember when I was working on some of these Renault medallions when they first came out in 1988, all of the wires on some of those harnesses would be the same exact color. Like they'd have just a whole bunch of red wires, and on each end of the wire they would have paint that was smeared on there, kind of like that right there. So you could tell that you were supposedly working on the same wire, but you could scratch that paint off with your thumbnail. And that's just really annoying. Some of the old Jeeps used to be like that. There was no real wiring schematic that you could use because the wires may be any color, kind of stuff, But anyway, you got to determine your circuit and component integrity. That's the next thing. So you got a hot and starter run. You might notice that. If there's this B plus up there, hot at all times or whatever. Now this particular schematic, when you see that going to another schematic, this right here is going to tell you that which diagram it is typically. And when you go to that diagram and you see where there is a K coming in, you'll know that it leaves here and it goes to that other schematic. Because these schematics are power. See that schematic I got on the wall right there? You see that one? That is the entire wiring schematic for a 64 Chevrolet Impala. That's the whole thing. There's no wiring on that car that's not covered on that one page. But now you can take, a lot of the times, some of the, there was a Cadillac Catera that I had to wire a schematic for. It's like 2 or 3 shop manuals. Wasn't that but wiring schematics, All right, so, but anyway, there you got your, let's say we're running a heated oxygen sensor. We got us a code. We know the oxygen sensor heater is throwing us a code. And so what we're going to do, well, is this one, I'm sorry. Well, we're going to take our ground our test light. We're going to go here. We're going to back probe, whatever we need to do, and see if we got power there. Now this is whenever we started to start or run, so it's got to be start. See, that's a splash right there, and it goes here. If that lights up, we know we got power there. You got ground here, you got power there, and you're getting a heater code, nothing to it but a sensor. Measure the resistance that actually supposed to have 6 to 8 ohms. You got that, there you go. If you want to, and I've done this a lot, you can, if you're thinking maybe there's a problem with the engine controller or something like that, you can hook a light between here and here. I get an old oxygen sensor connector and build me a little tool, plug it in, and if that light right there lights up, then I'll know that oxygen sensor, heater circuit is basically being fired up. It's got power and it's got ground coming in from the engine controller. Now this is to fix anything, you got to understand it. You see that this Sebring was running hot at stoplights. We fix this one here and drive-through lines. What might cause that? It's only running hot at the drive-through and when I'm at a stoplight. Who knows? You guys can do better than this. Come on. It's only running when I'm sitting still. What's the difference when I'm sitting still and when I'm going down the road?
You didn't have the air. For the cooler?
The fan.
Yeah.
Yeah, I mean, he was thinking in the right direction. If you got air coming through the front of it when you're going down the road, it stays cool, but when you stop, there's no air moving, it gets hot, that's gonna be a coolant fan problem, isn't it? All right, so we got an issue on that. So, let's see if I can get this thing to trigger. They're gonna be batteries. All this always points to a fan issue, just about every time. On the daily vehicles, it's a critical part of the coolant system, and that's what the fan looks like on that car. All right, so you got a low-speed fan relay on that one, and you got a high-speed fan relay. Now that fan right there, this right here is the way the GM wires theirs up, where you got 3 relays and 2 switches and all. That one right there, you notice you got that fuse right there is feeding the coils on the relays. The PCM turns on the relays, and it turns on that relay for low-speed fan and that relay for high-speed fan. That ain't real complicated, it's pretty simple. You should ought to see what they did on that 2006 Sonata trying to make that work. Boy, they got, went crazy on that. All right, hold on. This thing is not acting up. Fan strategy. Get the strategy down pat first. Fan comes on at 219, 104 Celsius, and 230 Fahrenheit is high. See, there's when it comes on. Turns off at 210 and 221 respectively. Find out what those is. Now here's another thing. The fan will not run during cranking until the engine starts, no matter what the coolant temperature is. All right, the fan will run with the air conditioner clutch is engaged, low pressure cutout switch is closed, and once that compressor head pressure is reached, then it'll run according to the following information charts. All right, I think my battery must be dead in my remote. Or something. All right, there you go. All right, there's your fuse panel. You see the low speed radiator fan relay? Up there on the top right. There it is. All right, we're gonna take a little bit closer look at that. And we notice I erased that one because we're not using that one. That one right there. In other words, that one in the middle is not being used at all. They don't even have it numbered on here. All right, so we got your low speed fan relay. Now what we can do is we can get to the one that's going out to the fan. This one here is going to be your common one. It's going to be the one that's bringing power in at 74, see there? And then 72 is the one that's going out to the fan. Now if I was so decided to test that fan, I could get a test light and get it hot, touch it right here in that cavity, turn the fan really slowly. If that light ever goes out, you got a bad fan. Always remember that. That's a good deal there. Look at that. That thing is absolutely not being nice to me. All right, when the circuit's working, right, and the relay is closed, the fan pulls 20 amps. Now watch this. Whenever you're measuring voltage, your reference point is ground, so you're going to see volts, volts, nothing, nothing, right? But there's a 20 amps everywhere in the circuit when the fan's running. In other words, if this fan pulls 20 amps, or if that one pulls 20 amps, you're going to see, 20 amps, 20 amps, 20 amps. So think about this. Don't miss this. You're going to see 20 amps everywhere, but you're only going to see voltage on the hot side. You got it? You got just as much amps down here. If you clipped an amp lead around that, it's going to read the same amount of amps that it reads here. But if you got your measurement, if you're measuring voltage, you're not going to read any voltage down there because ground is your point. You're measuring the amperage with a inductive probe. All right. Now then, let's see what we do here. Remove the fan relay. Pull that one out, get it out of the way. All right. Now we're going to find out, this is a true story. We found no power feeding the fan relay. That's battery. That means it's supposed to be hot all the time. Got a little test light here and put it there. And we don't have anything. No power there. So that's going to lead us where? Dakota's about to fall asleep here. He's looking at the wall and the ceiling and looking down. My grandson when he was at the barbecue shack. All right, here we go. That's what we found on that. This fuse was not blown. Fan circuits fail this way because a little bit of resistance in there, when there's a lot of current flowing, start to heat that connection up. I don't know if you ever felt anything that was hot when it's carrying a lot of current, starts to heat it up, starts to oxidize, resistance starts to build, that causes more heat, and it actually melts down the fuse. Now you might be looking at fuse and find it's not blown, it's just been cooked like that. Current flow stops throughout the circuit because of one failure point. That means there's no current flow going anywhere. Sometimes replacing the fuse panel you not need to replace the fuse panel in those cases. Always inspect the connections. Fuel pumps can do this, fans can do this. This was a headlight connector. This headlight connector failed for the same reason and in the same way. Now, if you plug a brand new connector into a headlight bulb with an oxidized tab, you're going to be courting the same disaster, right? You're going to be back where you were. A lot of times, even if the bulb's good, it doesn't mean it's going to keep working just because it's working to start with. Blower resistor in this connector failed for the same reason. See that melted terminal right there? This is fairly common on Ford Fusions. You'll have to replace this connector shell, and you'll also have to replace this blower resistor. But like I say, if you got an oxidized terminal right there, you're probably going to have the same deal again. What I like to do in a circuit like this is I like to put a little bit of dielectric grease on there, and it keeps oxygen away for it, and it keeps it from oxidizing. A lot of times you don't have a problem with it if you do that. There's some stuff called Stabilant 22 you can get that's really good for that too. Human error can be the cause. That created an engine skip. We put a vehicle back together, and the engine was skipping and throwing us a misfire code on some cylinder. I don't remember which one it was. And when we found the problem, it's because somebody had bent one of those pins when he was plugging a connector in. Just make sure you watch for that kind of stuff, because these things are slip. Now, relays are not always replaceable, right? See this one here? All right, let me give you a little bit of a closer look at that. You notice how that one there, that's a replaceable relay. The way you can tell it's a replaceable relay is because it's got numbered terminals. You see that? Really important to recognize that caveat. This is not a replaceable relay. This relay does not have numbered terminals, even though it's got a similar wiring schematic. In that case, you have to replace this whole module that the relay is built into. You determine the relay is bad. So if you're looking like for a fuel pump relay on some of the Toyotas, you won't find the relay because it's built in to a box, a junction box. That Hyundai out there has got little relays that operate the door locks that are built into the fuse panel. In order to fix the door locks on that car, because it's got oxidized terminals on some of the little relays, you'd have to buy a $750 fuse panel if you wanted to fix a door lock. No terminal numbers means you have to replace the entire relay module. And that's what I was getting at on that. Okay, we've had to do that here before. Measure and start current draw. Sometimes a motor or another component might pull too much current because of compromised windings. That pretty little copper wire on those windings on these motors, and I had a motor partly in here somewhere, is not just naked copper. It's got some shellac on it that when it's wrapped through here, the wire's not touching each other. It's basically the current is forced to follow the wire instead of jumping from wire to wire. If it gets compromised and it starts to burn through, you'll see it looking all cooked and burned and scorched like that. And even if the motor runs, it's not going to run right. And so burn motor windings in a fan motor can create radio frequency interference and make the fuel injection system do weird things because magnetic waves are going through the compartment. They're passing through those wires, making signals that the engine controller doesn't know what to do with. And I've seen that a bunch of times too. Now let's see if I can get this video to play. Let me back up. I'll get it to play the old-fashioned way since it's in the last slide. That's what I'll do. All right, let me go right down here. And I'm going to go in there. All right, let me go in here. I'm going to play that little video right there because it won't take but a second. It's real short. And somewhere, we got a video somewhere. Few thumbnails. Where is that? That's really something how you can't find it. You see a WMV file in there somewhere? Or do you have one? Maybe that one didn't copy over. There it is, right there. Bench test this here starter. All right, give it some juice. How's that sound? That sound okay? And a really lousy start. Let's hear it. And a really lousy starter. That's a bad starter. Really lousy starter. Now watch the good one. Look at the difference. You hear the difference? Bad starter, good starter. You might think that first one was okay until you heard a good one. See what I mean? Next, that's this here starter. All right, give us some juice. See, that's the same everything. It's the same connection, same battery. We had them starters laying side by side, and I wanted to make sure you saw that. So,